Okay, so today we are going to load some data into Python, and then we're going to use regular expressions to comb through that data for particular nuggets we're looking for, and then we're going to take those nuggets and put them in a dictionary, and then we're going to make that that dictionary so that we have dot access to it. And we're doing those second two things, loading into the dictionary and getting dot access, so that we can use this data easily in calculations. This data in particular is property data for different kinds of materials. And we're going to be using water as an example. And so here we go. So let's just make a few blocks that we can sort of start to strategize what we're doing today. So our first step, of course, we're going to do our installs and our imports. So imports, installs, and then next we need to get our data, and after we've got our data, we need to use regular expressions, or let's just call it regex, to comb through the data. Then once we've done that, we will put our data to dictionaries, and we can we'll put our data to dictionaries, and we're going to do a little bit of processing of the data once they're in the dictionaries. We're going to put abbreviated terms in place of the long terms that the data will come in with, and then we're going to convert everything to be floats instead of strings, which is what the data will be when it starts. Okay, so with our rough sketch, there's one more step, but we'll wait on that for now. So our rough sketch is in place, and so let's do our imports and installs. So the first thing that we're going to do is we're going to install we need the right syntax, don't we? pip install dot map. And let's just run that and make sure that all the syntax is groovy. And so this will be our install blocks, or cell, whatever the proper term is. And then let's do our imports here. So what do we need to import? Well, we need to import requests. That's what we're going to use to get our data. We need to import regular expressions. Let's import numpy as np. That's what we'll be using to do some of our processing. And of course, from dot map import dot map. And maybe let's just do this now. We also want to be able to plot some of this stuff to test it out and make sure everything looks good. So let's import from plotly dot subplots import make subplots. Import plotly.io as pio, and pio.templates.default equals, this is just a formatting thing, but plotly dark. There we go. Okay, and with that all in place, let's make sure there's no typos. Oh, there is a typo. That wouldn't make much sense. Yeah, from numpy, let's import numpy. Okay. Boy, we're off to a rip roaring start. This is called getting all your mistakes out of the way at the beginning. Okay, there we go. So everything's imported. Now let's get our data. So the data in question is coming from a GitHub repository, and that GitHub repository is I can thank Dr. Carlos Coe for the use of this repository. It's actually it's in a different spot. GitHub repository. You get the joy of getting to watch me click on things, which I know you were looking for. All right, here we go. So we're almost there. Water. All right, so here's our data. Let's look at the raw. So this is the data that that we're going to be pulling into Python, and we'll spend a lot more time looking at this data. Don't worry if it seems like a lot. Well, actually, we don't want to do that yet. First, we want to get it into Python. So, and to do that, let's see. Oh, so all the data is going to come in as a string. So I'm just going to call my data string to help distinguish it from the other forms that'll appear later on. And we'll just requests.get, and then that, and we want to bring it in as text. All right, and let's run that. Wonderful. And let's print data string, just to see that we've got what we. Okay, let's take a quick look, but it looks wonderful. Yep, that looks just like this. Okay, so we've got our data. Now let's look at this data and talk a little bit about what we're trying to do. So we have all these material properties. We've got molecular weight, yada 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 yada, and then some values over here. And so what we're trying to do is load all of these as keys in a dictionary and all of these as values in a dictionary, so that if I want the critical temperature for water, I can just I can access it easily, and out pops 647.35 degrees. I'm not going to worry about the units. That is, of course, units are very important, but today, for this smaller scale example, we're not going to bother with the units. And as we keep looking down through the data, we notice there are some different formats. There's this one-to-one kind of format, and then there's this second format, which has some property, a range where that property is valid, and then coefficients that are to be used in an equation. So, and there's a good number of these. And then there's a third area down here that I'm not going to focus on, but the same principles that we'll use to get the data for these first two sections would apply. So again, we've got these two different formats, and so this is where regular expressions come in. And I'm going to be using regex 101, and let's make sure we're on Python. Okay, and let's take our data and paste it in here. Make sure yes, okay, good. So here is our data now in Python. We can see all the spaces and all the new line characters. And so let's do first things first. Let's try and grab the data for this section. And looking at it, I can see it's pretty much what we expected before. All the lines that we're looking at for this first section start with a space. They've got same name for the property, which seems to be mostly letters, but at least in one or two places has some other character that's not a letter. And yeah, okay. And then some variable number of spaces, then a colon, another variable number of spaces, and then some primarily numeric, but with some special characters like a period, a plus, minus sign, string, then more spaces, the units if they're there, and then more spaces. As I said before, I'm not going to worry about the units today, so let's get started. So our first capture group is going to be one of these terms here, and so let's specify what we're looking for. Well, we are looking for lowercase a to z, uppercase a to z, and the number 0 to 9. And also got a slash. And is there anything else? No, and a slash. Okay. And then let's be greedy and put a plus sign there to grab larger chunks, and let's also grab spaces. All right, so now we've got something that's nice and orderly. It's getting us a lot. Oh, let's see. So let's just do a quick check and make sure we're grabbing everything we want. We can prune away once we've done that. Okay, so the only thing I'm seeing that we're not grabbing is that period. So let's grab periods as well. Boom. Okay, so what can we do to grab a little bit less now that we've got our big block of marble? Let's chip away at it. So the first thing I want to do is not get that space right there at the beginning. And the next thing is we want to not have all of these spaces either. And to ignore those, what I'm going to do is use the \b, which that detects borders between words and non-word characters. And so let's just check over that real quick. But it looks like we're stopping right on a dime every place we want to be stopping. Okay, and then we've got some variable number of spaces. So we'll just put a space there, and then we'll make that greedy. And then we will do a colon, and then another variable number of spaces, which we will make again greedy, so that we can go right up to the beginning of this next group of characters. Okay, and so far it looks good for this one-to-one formatting area. We've so far got everything that we need. So let's put our second capture group so we can grab these numbers. So oh, I should say this chunk here, lowercase, uppercase, and numbers, there's a shorthand for it, and I'm actually going to use that shorthand, and it's \W, and I guess for word characters. Okay, and now let's do the same thing here. So I'm going to use that same shorthand, and you can see, because we haven't made it greedy yet, it's just grabbing the very first character. So let's make it greedy with a plus sign, and let's add in some things that we're not grabbing so far. So I see the letter E. I see, well, it'll grab that because that's a word character. I see a minus sign, a plus sign, and a period. And I don't see anything else, but if there is anything else, it'll stand out. So we'll do a plus, period, and a minus. It doesn't like it when you put the minus in front of some of these other characters. Okay, and just like that, it looks like we've got our first expression. I'm not going to worry about the units for today. So let's take that and paste it back into Python. Let's get rid of this now that we've got it elsewhere. Okay, so we've got our little regex box down here, and we'll call it, I don't know, pattern one. Doop. And let's go ahead and process this now. So regular expressions dot compile, and then we want it to be a raw string, and let's put it in quotes, and let's set the flags, regular expressions, let's see, what is it? That's our multi-line, because we're going line by line. So we don't want to treat it all as one thing. We want to treat it as separate lines. Okay, so that's our first pattern. So let's go ahead and get our second pattern. And you know what, let's make sure that this runs and that there's not some syntax error. Okay, perfect. Okay, so this second area is a little bit trickier. So let's think about what we actually want here. Again, I'm not worrying about units right now. So we've got the property name, we've got an equation number, we've got the range where the equation is valid, and we've got these coefficients. I'm just going to be grabbing the property name and the number part of the coefficients. So I want to skip everything between this space and this space. I want to skip all of this range, the equation number, the coefficient, the label coefs. Okay, so let's start where we did before. There's no space in front this time, and so let's get our capture group, it's just going to be all word characters. Okay, so far, oh, and let's get spaces too. All right, so right now we've got a nice big block right there. That's good, but we're also grabbing everything that's up here too. So how can we make a pattern that will discriminate this line from this line? Well, you notice that for the second formatting, there's this equation number feature that's in every first line. That's not the same line that has the name of our property. And so let's find some way to make it only look at lines that have, let's say, the word number in it. So let's put another space there. Okay, so I want to eat up everything between here and the word number. So to do that, I'm going to make a non-capturing criteria, and that will be, I want everything but the next line character, or the new line character, not next line. And let's make it green. So there we go. Right now it's starting with a block of words and spaces, and then there's one space afterwards, and then it's just getting everything up to the new line. So far it's not distinguishing from the previous section, but now we can add number. So there we go. Now suddenly we are targeting these lines that we want to be targeting, or at least the chunks that we want to be targeting, and we're ignoring all of this. Now that we've done that, let's skip. Let's turn on dot match. So now we want to skip between here and there, and to do that, we're going to be very indiscriminate. We're going to do the dot. The dot matches all characters, and we're going to make the dot greedy. And right now we've made it so greedy that it's eating up everything for the rest of the block of text. So let's have it go until it reaches the word coefs. Unfortunately, it's being too greedy, so let's make it a little less greedy. Let's make it lazy. There we go. And just like that, we are capturing this first property, going all the way to coefs. Let's take care of those spaces too. Is it always two spaces? Two, 1. Okay, so let's make it a variable number of spaces. That's it. It's one or more spaces. Okay, and now let's get this second group. So capture group, and with criteria word characters, and let's make that greedy. But everything's getting stopped by the periods, so let's make sure that we're grabbing in our criteria, we're grabbing periods, and let's grab pluses, and let's also grab spaces, and let's grab negative signs. And are we getting everything? I think we are. Perfect. Okay. We can check over here if we want. Over here. So liquid density and then the numbers. Solid density, numbers. Perfect. Okay. So there's our second expression. Boop. All right, and we can just call this pattern 2. Pattern 2 to re.compile. We want a raw string and pop. And talk about flags. Remember, we set this to be we turned single line on. The way we're going to do that here is flags regular expression dot match, or dot all, not dot match. What am I saying? And that's just going to treat. That's going to let the dot character match everything, including the next line character. So it won't just go up to it. It'll get everything. Okay, and let's come. Oh, we closed our? Yes, we have. So let's. Okay, so it seems to have accepted everything. Now let's. Before we go on to putting our data in our dictionary, let's actually use these patterns on our data. And so the way we're going to do that, we'll make 2 temporary dictionaries. We'll call it props also have a coefs dict. Okay, and we'll just we'll use the dict command, and let's pattern1 dot find all. That's what I'm looking for. Find all, and then the text that we're looking at. So that's data string. Okay, and let's do the same thing. Well, let's run this. Make sure there's no syntax issues here. Perfect. Okay, and let's even take a look at it. Props dict, just to see what we're working with. Okay, and we've got a dictionary with that little curly brace. Dictionary with names and, well, not values. These are strings, but these will convert these strings into values in short order. So let's now get our coefs dict. Dict pattern2 dot find all data string. Okay, and we'll take a look at that too. So coefs, not doefs, coefs dict. Okay, and just like we were expecting, we've got our key, which is the name of the property, and then a long, right now, string of coefficients. Perfect. Okay, so let's go ahead to the next part of the pattern, or the next part of the process rather, and let's put all this data into a single dictionary, and let's also convert it into, and actually this is going to be data to dictionary and processing in one step. So, or in one block of code. So to do that, let's make what our final dictionary is going to be. We'll just call it props. And there we go. So let's iterate. So there are two things that we need to do as we're reading data from these different dictionaries into our final dictionary. The most important thing is that we need to make it so that these properties are readable as numbers. And the other thing we're going to do is for convenience, and that is that if we were to look at one of these again, look at props dictionary, you'll notice that these names are pretty long, and I don't know if I want to type out heat of vaporization every time I need this number. I'd like to use an abbreviation. So for that reason, I'm also going to make it so that this new dictionary, the keys will be abbreviations rather than full names. So we'll go from molecular weight to MW, etc. And this is a selection of the properties available. We could, of course, do them all, but we're just going to work with a few. And I'm going to save you all the pleasure of watching me type all of this, so I have it pre-typed. Okay, and let's get that in there. Okay, so now let's do the actual processing. So the first thing to do is let's read these dictionaries in one at a time, and so I'm actually going to iterate through this dictionary and not this dictionary. And the reason I'm doing that is that this dictionary is shorter, and so it won't take as long. I mean, not that it'll take a tremendous amount of time at this scale either way, but in principle, it's good to optimize your efficiency wherever you can. So let's do some iterating. For key value in, let's do the single props first. In extract single props, and I'm iterating through both key and value, so I'm gonna go through extract single props items. And so for every key and value pair, I'm gonna go through this, and let's make a new entry in props. So we'll say props, and we want that entry in props to have the key that corresponds to this abbreviation. So the key in props is going to be the value in this extract single props dictionary. So for a key and value in this, the props is going to be the same thing as the key in this other. So for props value is equal to, let's see, when we called it props dictionary, props dict, and key. Now let's go ahead and do this, even though it's not right, and then we'll take a look at it just as a reminder. So we'll look at props. Oh, syntax. Let's go ahead and print out props dict again. Props dict. So there's a key difference between this dictionary and this dictionary, and it's not just that they're shorter. You notice this dictionary has a space in front of every single property, and there's not one here. And so when it's trying to go through and match, well, none of these start with a space, so it's not finding any matches in this dictionary. So let's make sure that we there we go, that we're scanning for that space. So doop, and there. Now that space is gone. We put it outside of our capture group. And so let's run this again. Although I guess we didn't need to, and run this again. Okay, so now we've got our keys and our values. They're in this new dictionary. We've got our abbreviations, which we wanted, but we've still got a string over here. You notice the single quotes. So let's make this into a number. We'll do that. We'll make it a float. And let's try again. And voila. So there's our first successful migration of things into the final form that we were looking for. Let's now iterate through the second dictionary, and so we'll do the same thing again for key value in extract coefficient props items. And now here we have a slightly more complicated situation, because we're bringing in something that we want to read as an array. But let's go incrementally. So we'll say again props value is equal to coefs dict key. And let's just do that again and see what it gets us. So it's getting us the abbreviations just like we wanted, but now we've got this long string that NumPy or any other mathematical library in Python wouldn't really know what to do with in its present form. So let's convert it. But before we convert it, we have to split this string up. So let's do that. Let's split it. So let's and run that again. Okay, now everything's split up. We're still in string form. And so let's convert this into a NumPy array. And let's bring it in as type NumPy float. Let's make sure this is working. Okay, wonderful. So there we go. We've got our property name that's abbreviated, and then we've got an array of honest to goodness numerical values that we can use to calculate things. So let's make sure that this all works. Let's calculate something. So we're going to use this pvap set of coefficients, and to calculate vapor pressure. And there's one more thing that I said I would do before that we haven't done yet, and that's let's make these values dot accessible. So doing that is trivial. We're just going to go props is equal to dot map parentheses props, and just like that, let's see, looks like nothing. Just like that, if we want to go props dot, I don't know which one of these values do we want. Let's get the boiling temperature. So props dot TB, and there we go. It returns it easily. We don't have to do anything complicated. It's very simple to just go props dot and then the name of the property that we want. So with that in mind, let's go ahead and put these things into an equation. Now, the form of this equation, I won't take your time with looking it up because I happen to know it. The form of this equation, well, we'll just define a function for it now. So we'll define pvap t. I should probably call it something. Pvap water. It's a function of temperature, and we'll just return our value directly. We won't be complicated about it. And the form of the equation is np.exp. And here is our form. So I could have given, by the by, all of these constants names. That wouldn't be terribly hard to do, but since it's all going to be inside of this function anyway, I'm just going to index through these arrays. So let's so the form. So if we want to index and get one of these constants, the way we'll do that is we'll go props dot, and then we're looking in pvap, props.pvap, and then we need our index. I'm actually going to copy this because otherwise I'll be typing it 5 times. So the form of the equation is our first constant, which is right here, plus t divided by our second constant, plus our third constant times the natural log, which we can just go np log, times the natural log of t. And let's go on a little bit further, plus our fourth constant, which is props.pvap, times t to the power of our fifth constant. And of course, Python indexes from 0, which is why the numbers are what they are. So let's make sure that there's no, okay. So far so good. Let's use our function for something where we know the answer, just to make sure that everything went through all right. So we actually have this TB up here. So let's use this. We know that at the boiling point of water, the water starts to dramatically change state between a liquid and a gas, and that's because the vapor pressure of water at that temperature and at standard pressure is equal to atmospheric pressure. So we should get atmospheric pressure in pascals, I believe. This is one reason to get the units. Must have missed it. Heat of vaporization, vapor pressure. Okay, in pascals, yes. So we should get back the vapor pressure in pascals if we enter this temperature. So let's do it. We'll go pvap water, and we can just, for fun, it would actually be quicker to type out 373.15, but let's go ahead and put props .tb, and let's see what we get. Well, we'll just print this directly. Print. Okay. That's a little high. So clearly there's some issue. There's some issue in our equation. So I think I'm going to have to look it up after all. Let's ChemCAD property calculations. Is this the property data? Okay, and if we remember from over here, we're looking for equation 101. So let's just search that real quick. Equation 101. So have I got the correct form? Let's just double check. So exponential of our first constant plus ours. Ah, that's where we went wrong. Oh well. Score one for double checking. So now let's just make sure all the other terms are correct. CLNT props D times 2. Okay. All right. I'm hesitantly optimistic. Let's run this again. And then let's. Okay, and there we go. That's awfully close to 101.325. You know, we're 7, well, almost 8 pascals away, which is a tiny amount. So that looks to me like a success. If we wanted to, we could go ahead and graph this and get the full curve. Let's see what time we're at. Okay, rather than do that, because you probably already know how to do that. Here's something. If you're sharing something that has regular expressions, this is my last dab, my last little extra bit. If you're working on code with someone else, and that someone else, either they don't work with regular expressions with great frequency, or they're just, you've got a long confusing expression and you want to make it easily accessible for them, then you can do what I'm about to do, which is we're going to make our expressions verbose. What does that mean? That's not what I wanted to do. We're going to make our expressions verbose. That's something to add to the flag section over here. We can either spell it out verbose all the way, and why not? We could there's also a I think it's .x, but let's put it here too. I'll just do it for the one case so you can see how it works. So what this will allow us to do is have little comments next to each section of our code, so each section of our regular expression, so a person can look at it and go, oh, I get that, because it'll be broken down section by section. The only thing that you have to watch out for, I have a couple of spaces in my regular expression, and when I have this flag on verbose, it will ignore those spaces because you have a lot of spaces between the bit of your regular expression and your explanation. And so what I'm going to do now, I probably should have done before, and that is use the \s character to represent the space. And if it all blows up, then that'll be a lesson to me. So let's first run this just to make sure that it doesn't freak out. Okay. Well, we're back to that. Okay. Rather than do the \s, we'll do something that's not pretty, but we can just put a space inside a bracket. Anybody who really knows regular expressions would probably tell you that It's a terrible way to do it, and it probably is, but it's going to work for today. And so let's just run this. Okay, and now we're getting back what we want. So now let's break this thing down. So our very first thing that we have, our very first thing that we have is this new space character. But let's just break things up. So that's our first section. There's our second section. Oh, the other thing we need to do is we need to make this a multi-line string, and let's end it down here. Okay, and let's go like so. We can just break everything up bit by bit, and there we go. Okay, so we can just add little comments like, oh, what the heck? We'll put this on a separate line too. So we can just put a little comment and it will be ignored. So this is our initial space, and this is our property name. This is variable spaces. This probably doesn't need an explanation. This again is variable spaces. And then this is our property value. And just like that, we've got something that a person who maybe they know a little bit about regular expressions, but they're not comfortable with them, or if we had a much longer, more complicated expression, we've got something that would be much more accessible to a user of the code. So let's run that and make sure there's no issues with it. And let's go ahead and run everything else just to make sure that there are no hidden issues. And finally, okay. All right. Thank you so much for following along with me today. Have a wonderful day and happy coding.